So how's your holidays? Enjoying? Okay, let us recall what we have discussed last week. So last week we have discussed how to establish, or we said how to draw X bar and R control chart. We also discussed the process capability. There are a few ways for this process capability. So last week we have discussed process capability ratio, PCR. That is the short form, or we say acronym. Process capability ratio, PCR, or just use the notation CP. And the formula to calculate this CP, you can see on the screen, is given by equation 6.11. USL stands for upper specification limit. SL stands for lower specification limit. So we get the difference of this specification limit, upper minus lower, and then divide by 6 sigma. Sigma is come from the population standard deviation. If the sigma we don't know, then we have to estimate the value. Then how to estimate this sigma? In notation, when we estimate this sigma, it is given by sigma head. Okay, in notation form, sigma head is the estimated standard deviation. And you can read from the screen, sigma head is equal to R bar over D2. R bar is the mean of range. And then D2, the value of D2 we can read from the table in appendix 6. And the value of D2 actually depend on the sample size. Yeah, you can have a look in appendix, in the table in the appendix 6. Make sure you know how to pick up, or how to choose, or how to refer the value of D2 from the table. So to calculate the CP, not a problem. We just substitute the value, estimate sigma's value, and then read the D2 from the table. So put all the value in order in the equation form, and then do the calculation. But I have mentioned to you last week, make sure we not only can do the calculation, but we also can do the explanation, or we say interpretation. I mean, we can explain what does this CP or this CP head stand for. So from this example we have discussed last week, for UCL2 equal to 2, for USL equal to 2, okay, for USL equal to 2 and SL equal to 1, and then we estimate sigma, which is sigma head is equal to 0.1398. So after the calculation, we get CP head 1.192. So what does this 1.192 means? So I have mentioned to you that to highlight the sentence, this implies that the natural tolerance limit in the process are inside the lower and upper specification limit. Then what does it mean, natural tolerance limit? You see, this sentence, there are two limits. The first limit is natural tolerance limit in the process. And then another limit is for lower and upper specification limit. So this 1.192, where should we put in this 1.192 in the sentence so that we can make the sentence make sense? If not, then every time we calculate CP head, not necessarily we get 1.192, maybe some others value, but we come up with the same sentence, same interpretation, same sentence, same one sentence to interpret. But what does it mean? Especially for 1.192 or for others value we calculated, it should have a meaning, right? Have you found it? No. You are enjoying you were enjoying your holiday, so you didn't have much time to find out. Yeah, I think in the next two chapter, process capability, yeah, we will discuss it again. So hopefully when we discuss that topic, process capability, then some of you or all of you can give me some feedback regarding to the interpretation. Okay, regarding to interpretation of CPH. So we also discuss how to calculate the quantity given by P equal to 1 over CP and then multiply 100%. So this is the percentage. We say percentage of the specification band that the process use up. So for the example we have discussed, hard bake process, an estimate of P. So from the previous CP head value, 1.192, we take 1 over CP head and then multiply 100%. So we get 83.89%. So this P head equal to 83.89%. Then what does it mean? So each calculation and each result or each the solution or each outcome of the calculation, then we should able to explain it. The meaning, what does the meaning means? What does the meaning stand for? Or what is the meaning of that value? So this P head 83.89% means that the process use up about 84% of the specification band. So you compare this sentence and the previous sentence I read. So this sentence is much more understandable, right? Because we have add in the percentage 84%. And then when you read through the sentence, the process use up about 84% of the specification band. Then it is related to the value or the outcome we have calculated. Rather than the previous sentence, this implies that the natural tolerance limit in the process. So 3 sigma above and the below, the means are inside the lower and upper specification limit. Then in the sentence, we do not see where is the value 1.192. So if compared to the second sentence, so second sentence would be much easier to understand, right? But for the previous sentence, so we have to already understand what does this 1.192 means for. Although I have read for you the sentence for interpretation, but that sentence is too general. So that's why I suggested that we have to find out where should we put the value 1.192 in the sentence so that we can make the sentence more understandable. Rather than every calculation you use the same sentence, then actually people might not understand what is the value 1.192 stand for. But for P head, it's very clear, isn't it? The process uses up about 84% of the specification band. So although we have do the calculation 83.89, in the sentence we said use up about the process use up about 84% is okay. If you want to write 83.89% of the specification band, also can, not a problem. This 84% is just to write this percentage in integer form. So 83.84, so round it to nearest integer, so it will be 84%. If you don't want to round it, then you will write down 83.89%. So not a problem. We also have discussed this figure to understand the CP head or CP value greater than 1, less than 1, equal to 1. You try to understand these three figures and you try to link with this value. You see, 1.192. So if CP head greater than 1, what does it mean? And you can see from the figure, you see, actually it means that this value, natural tolerance limit, is inside the specification limit. So this is from the graph what we see. But what does it mean? I mean, what is the meaning behind the figure? From the figure we know, yes, CP head or CP value greater than 1. It doesn't matter 1.192 or 2.192 or 1.5. It doesn't matter as long as CP head is greater than 1. Then we can say, or we should understand that natural tolerance limit is inside the specification limit. Yeah, this is what we can see from the figure. But if natural tolerance limit is inside the specification limit, then what is the meaning behind? If CP or CP head less than 1, you see, A and C will be opposite, right? A and C will be opposite. And then for the middle one, CP equal to 1, then natural tolerance limit and specification limit will be the same, will be equal. We also have discussed the phase 2 operation of charge. There is one keyword we use in phase 2, monitor, monitor or monitoring. And we have discussed the additional sample for example 6.1. I don't know how many of you have tried to plot the control chart. Figure 6.4. Have you tried? Yeah. I know you are so busy. You find out your time to try. If you still cannot find your free time, not a problem. You can try to plot your first control chart during your midterm test or in your final exam. Not a problem for me. I suddenly recall something for a moment. Yeah, I suddenly recorded regarding to your midterm test. So our midterm test is planned on week 7. Week 7, so another. I get the wrong calendar. Week 7, which is next week. But I get the notice from coordinator. Our midterm test will be postponed after week 9. But the actual date, I am not sure yet. I don't have information about the actual date. I only have the information. I only noticed that, or I only be informed that our midterm test after week 9. So don't worry, I will let you to know the actual date after I get the information. Okay, so continue. So I don't know how many of you have tried to plot the control chart in figure 6.4. If you have tried, if you have tried to plot this control chart in figure 6.4, did you get the same figure? If yes, congratulations. It means that yes, you understand. If no, please spend your time to plot. Don't think that plotting the control chart is very simple. You just overlook. You just look back. If the question asks you to establish the control chart, so you just do the calculation to calculate the control limit, and then control limit, and then find the center line, and then you plot the point, isn't it? But how if I ask the question reverse? What does mean reverse? Reverse means that explain. Okay, you no need to plot the control chart, but the question might ask you explain how you plot a control chart. So this is reverse thing. Okay, reverse things. Normally we are given a question and the question will be direct. Okay, for example, the direct question: draw a control chart, or draw a X bar control chart, or set up a control chart, or establish a control chart. So you just simply do as what we have discussed: calculate a control limit, and then put in the points. That's all. But if we do the reverse, so we no need to plot the control chart, but we explain. Okay, we explain how we want how we can plot a control chart. You have to think about it. So this is regarding to the reverse question. This is not a complicated. This is not a tricky, or this is not a complicated question. Actually, it's a direct question. Just ask you to explain, to test, to know whether you really understand how to plot a control chart. So if you haven't tried to plot control chart in figure 6.4, so please spend your time. I know you are very busy, but plotting a control chart not spend you too much time. And in figure 6.4, actually we have add in the additional. Okay, we have add in the additional sample from sample 26 until sample 45. I mean, we add in the extra subgroups. And then we want to notice, we want to observe, is any assignable cost happen, or any out of control signal happen. Then regarding to assignable cost, so this one is very subjective, but we have to mention, or we have to explain the assignable cost subjective. Subjective means that you can mention any assignable cost which give the quality issue. You can think from the appearance of product, you can think of the dimension of the product, you can think of the function or the features of the product. So anything regarding to the product and the quality issue, yeah, you can mention. We also have discussed the difference. What is the difference between control limit and specification limit? So in our discussion, we have mentioned that the control limit is come from the process. Okay, a process. So remember this process, when we mention a process, yeah, we understand that, yeah, we are mathematician, or we are statistician. When we mention about process, any process you know, maybe you may say yes, learning process. But do we only understand, or do we only can mention, do we able to mention learning process, or we just know learning process? Any other process we can mention? Yeah, of course. A manufacturing. Yeah, think of manufacturing. Any process? Baking process, packing process. What else? So there are many processes in the industry, isn't it? Then how about the service? It could be service process, right? But normally when we're talking about service, we won't say service process. We will say service quality or service response. Okay, service response, service quality. And for the process, normally it go through a time period and come up with a certain product or an outcome. So that is process. Making process, manufacturing process. So to get the control limit, we need to collect a set of a sample. Okay, we need to collect a subgroup or a sequence of sample point from the process so that we can calculate the control limit. And then for the specification limit, so this specification limit normally is determined by customer or determined by QC or QE or even manager, QC manager. So if we use two words to differentiate this control limit and specification limit. So this control limit is regarding to process. So we can say it's about internal. Okay, internal. It means from inside the process data. Specification limit, we can use the word external, from outside, determined by other people, not from the process, but some other people, or we can say, as I mentioned just now, QC, QE, even R&D engineer, they fix the specification limit. For example, the dimension of a handphone. So designer will fix how large or what is the thickness for a handphone they want to produce. So they determine the apparent. What is the color? So they determine. But during the making process or during the process, so does the process in control or out of control? Then we collect the sample from the process and then calculate the control limit. So hopefully you can see the difference between these two limits. And again, I want to emphasize that there is no mathematical or statistical relationship between the control limit and the specification limit. Yeah, this is true because these two limits are determined by different group of people. So no other statement saying that out of control, then because of the specification. No such thing. I mean, no mathematical or statistical relationship mentioned about this. And we have discussed the rational subgroup. S-chart monitor the between sample variability. So this is another keyword in quality control, variability. So we have between sample. We also have another word, within sample. So R-chart measure within sample. And then standard deviation estimate of sigma, which is given by sigma head, is used to construct control limit from the within sample variability. So make sure you really understand the keyword between sample. What does it mean? Within sample. And we put them together for between sample variability, within sample variability. What does it mean? So this is the standard keyword we use in quality control. But actually, if you already learn in statistics and probability, actually you can find some similar word. Yeah, I said if you already learn, because why I say you already learn, because I understand that after the final exam, you may not remember what you have learned. If you already learn, it means that you already understand. You can see there is a formula at the bottom. That is the formula we use to calculate the sample standard deviation, isn't it? But in quality control, we do not. Okay, we do not use this formula. And you can notice that from our discussion so far, we don't use this formula to calculate the standard deviation. When we calculate the standard deviation, when we want to construct the control limit, again, we want to construct a control limit, so we will use the standard deviation, but we don't use this formula, the formula I mentioned on the screen at the bottom. So we don't use that formula, although we know that formula is for sample standard deviation. But in quality control, we do not use it. We use other formula to calculate the standard deviation. So please refer to 6.4 and 6.5, how to calculate the sample standard deviation. Even you can see on the screen 6.14, 6.15, 6.16. These are another three standard deviations, no, control limit with standard deviations. So which part or which element are called standard deviation? So you look at 6.14, 3 sigma over square root of n. Sigma over square root of n. So this is the sample standard deviation, isn't it? A alpha, no, sorry, A sigma, also given by, no. If compare 6.14, okay, compare 6.15 to 6.14. So in 6.14, sigma over square root of n, okay, sigma over square root of n, this is a sample standard deviation. And 3 refer to the 3 sigma, okay, sigma level is 3. It means the distance from center line to upper control limit and the distance from center line to lower control limit. So this distance is 3. If we measure the distance from UCL to LCL, then it will become 6. Okay, so the 3 sigma level, this is the distance from center limit to UCL. The distance from center line to LCL. Okay, these 3. And then okay, now let's see 6.15. Again, you can see mu plus minus A sigma. So the sigma, this is the sigma for standard deviation. Okay, sigma stands for the standard deviation for population. Again, if sigma value we don't know, then we have to estimate it. Then we can use this simple, okay, or we say more general compared to 6.14. 6.15 is the more general control limit equation, which is given by mu plus minus A sigma. Again, this capital A is the sigma level. Then how about 6.16? 6.16 is totally different compared to 6.14 and 6.15. You see, upper control limit and lower control limit, we have D2 sigma plus 3D3 sigma. So there are 2 sigma in the equation compared to 6.14 and 6.15. So sigma, okay, sigma is written, or sigma is after the signs plus minus. But for 6.16, before plus minus we can see a sigma. After plus minus we can see another sigma. And these two sigma are the same sigma, same value. Then what is different? Or maybe we might ask, when we use 6.16, yeah, I can give you a question. Not necessarily I provide you the solution. Not necessarily I provide you the answer. Maybe you need to think about it, or maybe you need to find out your own. We also have discussed the pattern. So in this slide, there are 4 patterns of control chart. So from the pattern of the control chart, we should able to give the interpretation, or we should able to explain. For figure 6.8, so you can see the cycle, okay? The curve shows us there is a cycle on the control chart. And then for 6.9, a mixture pattern. I don't know whether you see the mixture pattern or not. So this mixture pattern is mixed by 2 bill sheets. And 6.10, a shift in process level. How to know is a shift? How to know a shift in the process level? And then 6.11, a trend in process level. So I come up with 2 questions. How to know a shift in process level? How to know a trend in process level? How to know? Or how to recognize? Yeah, this control chart is a shift in process level. And this is a trend in process level. And the next one, a stratification pattern. Hopefully you can see from 1.10, 1.11, 1.12. Almost the same, right? The figure almost the same. But the shift, even the direction also, the shift and the direction are not the same. Okay. Okay, I think you can observe something from the figure I had mentioned. We have discussed the effect of non-normality. So it's not a problem. There is an assumption in our discussion or in quality control data. The data should be distributed, should be normally distributed. But what if the data is not normally distributed? It means that the data do not follow the normal distribution. Then what can we observe, or what can we do, or what can we see from the control chart? And for the operating characteristic function, I have mentioned to you, this is type 2 error, and we will discuss this one in the last chapter, acceptance sampling. Yeah, if you cannot wait until last chapter, you can have a read. Actually, it's very easy to understand, and the calculation is very simple. Okay, so these are what we have discussed last meeting. So today we will go to another control chart, another pair of control chart. We call control chart, we call X bar control chart and S chart. We'll refer to 6.3. Control chart for X bar and S, or we say X bar and S control chart. So in the previous K of control chart, we understand that capital R is for range. Okay, capital R stands for range. So we calculate the range. Okay, we calculate the range from the sample data, and then we find the mean of the range, and then we calculate the control limit. After that, we plot the control chart for R, okay, for R or for range R. So today we want to discuss how to construct control chart for X bar and S. And actually you can see we have S and S squared. So this small letter S is stand for the standard deviation. And then this S squared is for variance. Okay, I repeat, small s, okay, when you're talking about small s control chart. So this s, small s, is for standard deviation. Okay, S stands for standard deviation. S squared is for variance. So in the other word, we will calculate the standard deviation before we can calculate the control limit, aiming to plot the S control chart. And then for S bar and S control chart, if we want to consider variance, then we have to construct S square control chart. So S and S square actually is a difference, although we understand that when we put S square, we get a variance. We put S square root of S square, we get standard deviation. But actually, the what I mean is the control chart, the pattern or the shift of control chart for S control chart and S square control chart, not much different because one is S squared. The different thing is the value. Okay, the value itself, one is S, one is S squared. This is from what we can see. And another thing we not see from the formula or from the physical, when we use standard deviation, when we should use variance, this thing we have to alert. Okay, we have to alert because sometimes we no need to use standard deviation, but we use variance. But sometimes we want to use variance. We won't care about standard deviation. Okay, so I think we can just start, right? Okay, 50 of you, another 20 of you, don't know where are them, but it doesn't matter. It's okay, no problem. Maybe they can read by themselves. Okay, for control chart, for S bar and S control chart, yeah, as I mentioned to you, no need to read sentence by sentence. I know many of you like highlighting the sentence or highlighting the key point. So yes, you can highlight 1 and 2, but not necessarily you highlight all the sentence. So this is for the sample size n is moderate, large. Set n greater than 10 or 12. If you compare S bar and R control chart, so it mentioned 4, 5, or 6, right? 4, 5, or 6. But for S bar and S control chart, we can consider n greater than 10 or 12. Of course, 11 also can. 10, as long as n is greater than 10 or n equal to 12. So it means that we can take n more than 12. Even we can take n equal to 20, not a problem, right? So this is the difference compared to the R control chart. And then the sample size n is variable. So there are two cases, okay? There are two cases for S bar and S chart. And these two cases are not in S bar and R chart. Again, In R chart, we consider n equal to 4, 5, or 6. But in S chart, we consider n greater than 10 or n greater than 12. And then we don't consider sample size n is variable. So what does it mean sample size is variable? If you refer back to the previous X bar and R control chart, the sample size is fixed. Okay, subgroup 4, 5, 6, they are either 4, 5, or 6 subgroups, and the sample size always fixed, 20 or 25, always fixed. For the subgroup we consider, they have the same sample size, 20 to 25. Normally we will take 20 or 25. The value of sample size is fixed. But for X bar and X control chart, so one of the case we might consider is the sample size is a variable. The sample size is variable. So the words variable, it means that the sample size not always the same. It means that not always 20. It can be 20, it can be 21, it can be 5. So the value of n, okay, the value of n is not fixed. For each sample, the size would not be the same. It can be different. Okay, so we'll discuss these two cases under the X bar and X control chart. But of course, for the second case, the sample size n is variable. The second case is much more interesting. Yeah, before we can construct the control chart, the first thing is how to calculate the control limit. When you ask this question, how to calculate the control limit, then we have to know what is the formula or what is the equation we can use to do the calculation to know the control limit. Yeah, you can see from the screen, equation 6.27, equation 0.28. And you can set this equation, okay, equation 6.27, equation 6.28. I think you refer to equation 6.27 first. Equation 6.27, so the formula we use to construct the control limit for S control chart is very similar to the control limit, to the formula or to the equation we use to calculate the control limit for R chart. Do you notice that the similarity? What is the similar? They don't have the plus term, right? I mean, if you compare 6.28, we have X bar plus minus A3 X bar. So you can see equation 6.27, you compare with the control limit, R control limit for R control chart, and then 6.28, you compare to the control limit for X bar control chart. You can find the similarity. Again, B3, B4, A3, okay, B4, B3, A3. These three value we can refer from the table in Appendix 6. Okay, we can refer to the table to read their value. Okay, we just go through some discussion. Yeah, this is the normal thing, because in the real situation, we may not know what is the real sigma's value. So if no standard is given for sigma, so means that we don't know what is the value of sigma, real sigma value. Then what shall we do? So we have to calculate from the data we collected. Then if we can collect a set of data, then how to calculate the value of X bar? So be careful when when we use the notation. Suppose that M preliminary samples, okay, M for the preliminary samples, each of size n, and then Si is the standard deviation of the I sample. And then we can calculate the average of M standard deviation by using the formula. So you can see this formula or this equation. Yes, this is the means. Okay, this is the formula we use to calculate the average or means value. And then the statistic X bar divided C4 is an unbiased estimator of sigma. So again, this sentence, S bar over C4 is an unbiased estimator of sigma. So from the statistic and probability, from that course you have taken, so we should able to prove, okay, we should able to prove the estimator, or we should able to prove the estimator is an unbiased, or maybe we turn around or we change the question. How to know, how to get the unbiased estimator of sigma? Yeah, this is one of the point, or one of the technique we learn in statistics and probability course in sampling topic. How to know, or how to calculate, or how to prove an unbiased estimator. Yeah, because we have learned in statistics and probability course. So I just remind you, you try to recall something. Actually, there are many things we have learned in statistics and probability. If you don't have any idea, it means that you might overlook something, or you might forget something. So please refer back your statistics and probability course. The parameter of the S chart. So if you refer back here, UCL S bar plus 3 S bar over C4, and then multiply with square root of 1 minus C4 squared. If we take minus, then we have lower control limit. Yeah, if you notice that, I believe that some of you might ask, how to know, or how to get S bar over C4 and then multiply with square root 1 minus C4 squared. How to know, or how to get this term? But from the comparison, we know this term S bar over C4 squared of 1 minus C4 squared. This term, this expression actually is come from the standard deviation, isn't it? If you compare to the general control limit, mu plus minus 3 sigma. Okay, we just simply compare this expression, mu plus minus 3 sigma. So it's very clear, 3 stands for 3 sigma level. Then of course, the expression after 3 will be the standard deviation. So again, we do not use the formula standard deviation we learned in statistics and probability, but we have others formula. Okay, we have other formula to calculate this standard deviation, which is given by S bar over C4 multiplied with square root of 1 minus C4 squared. We can define the constant B3 and B4. And this capital B3 and capital B4 are in equation 6.27. So in the other word, capital B3 and capital B4, either we read from table in appendix 6, or we use equation 6.26 to calculate B3 and B4. But notice that to calculate B3 and B4 by using the formula, you can see here C4. Okay, we need to know what is the value of C4. Then where to get the value of C4? Again, we can read the value of C4 from the table in Appendix 6. So it depends on the question. Either we need to read C4 from the table, or we read the capital B3, capital B4 from the table. Okay, it depends. Okay, so after we have done, after we have known control limit for S control chart, then go to the control limit. Okay, now go to control limit for X bar control chart. Again, X bar plus minus 3 times 3 times S bar over C4 square root of N. Yeah. So this is the formula we use to calculate the control limit for S bar chart. If you compare this formula, this control limit, okay, if you compare this control limits formula to the control limit for S bar and R chart, do you find the similarity? Okay, so compare. Let's compare 6.4, I think. Okay, this is a 6.4. Although they are called X bar chart, but in different S bar and R chart, S bar and S control chart. Although both of them have S bar control chart, but the formula we use to calculate the control limit for S bar chart will be different. So this is for X bar and R control chart. So 6.4, this is the equation we use to calculate the control limit for S bar control chart and R chart. Notice that plus minus A2 R bar. But for S bar and S control chart, just now is A2, isn't it? But now it's A3. A3 is equal to 3 over C4 times square root of N. So this is A3. How to calculate capital A3? Yeah, this is the formula. You can highlight. Or no need to calculate. Okay, no need to calculate for A3. We can read A3's value from the table in Appendix 6. Yeah, so far any question from you? So actually you can notice that for our course, IQC actually very simple, not difficult. If you find difficult, means that your statistic and probability basics not enough, not strong enough. But this is not a problem because you can study, you can, if you don't understand, you can ask a question, you can personally WhatsApp me if you have any question. Okay, let's see one example. You see the question is quite simple, right? Construct and interpret X bar and S chart using the piston ring inside diameter measurement in table 6.3. Very simple. Where is that table 6.3? Yeah, this is table 6.3. So I don't know how many of you have get ready, how many of you have gotten ready or have get your table 6.3 ready. Have table 6.3 ready with you. So if you have typed, if you have prepared table 6.3 with you, so suppose you have typed sample number, first column 1 until 25, and then you have typed observation 1, 2, 3, 4, 5. Yeah, I repeat, sample number, the first column, and then observation from the second, third, fourth, fifth, sixth. Okay, for the following 5 columns. Yeah. So these are the data we collected from what? From the production, from the process, or from automobile engine piston rings. You see, before that we mentioned a process. It also can be referred to, you see, inside diameter measurement. So this is not a process, but it's regarding to what? Regarding to the measurement. Not a process, but it's a measurement. Inside diameter measurement. So this is I think this is one of the problem. If I ask you to collect the data from industry, we have tried to ask your senior to collect the data from industry. I don't know how they approach industry, but finally they got different data, and then they don't know how to use the data. Okay, come back to our table 6.3. For the last 2 column, okay, for the last 2 column, XI bar and SI. So for the last 2 column, it's not from the data. Okay, it's not from for the last 2 column, those values are not from the data. I mean, we don't collect the value in the last 2 columns, but we calculate. Okay, the last 2 columns value are calculated, but not collected. Those collected are the data. I mean the data from column 1, 2, 3, 4, 5, 6. Okay, for the first 6 column, yeah, they are data. Again, sample number. So it's just a labeling, right? Sample 1, sample 2, sample 3. And then observation, or we can say subgroup. Okay, observation. So now, when you look at this sample, or when you look at this table 6.3, M equal to what? M Malaysia, M equal to what? Nasi, N equal to what? Make sure you don't confuse. Don't actionable, or don't exchange, or don't misunderstand the value of M and N, because we will use them to calculate. At the bottom of the table, yeah, this is the writing I not prefer. Why? You see, summation, yes, we understand the summation is 1850.028. We put summation, yes, we understand this is the summation notation. We get the sum of xi bars columns value. But from here, we don't know m's value, right? You see, you look over, you have a look in table 6.3. In the table, m equal to what? N equal to what value? We don't know. But we have to understand, or we have to alert ourselves. M equal to what and N equal to what? You see the following. No more. Is here. Okay, you look at the solution. X bar is equal to 1/25. Yeah. So if you refer to the equation we have discussed just now, so the formula should be 1 over m and then sigma I equal to 1 to m and then xi bar, isn't it? So m equal to 25. So m equal to 25. So use the formula x bar bar. No, use the formula of the mean to calculate x bar bar and s bar. So I believe you can calculate these two values x bar bar and s bar. Again, remember this x bar bar and s bar are the center line in the respective chart. So x bar bar equal to 74.001. So this is the center line in x bar control chart. X bar equal to 0.0094. This is the center line in X bar control chart. After we calculate the center line or the average value, then what is the next? Use the equation to calculate the control limit. I have to remind you, you have to do something. Again, you need to do something to either to remember the formula or to understand the formula. So, how to calculate UCL for X bar chart, X bar control chart? Again, you see, use the formula X bar plus minus A3 X bar. Yeah, if you don't know or if you cannot remember the formula, of course you cannot calculate control limit. So after we calculate the control limit for X bar and S control chart, have a look. But I suggest that you don't just have a look. Can you try to press your calculator? Yeah, although the solution are already in front of you, but please pressing your calculator 74.00 plus 1.427 times 0.0094. Do you get 74.014? Yeah, you try to press your calculator to double check the value, to get the feeling, to get the experience on calculating the control limit. If not, then when you want to calculate, do not tell me, sir, I will calculate when I'm free. But when are you free? So why not you spend, I don't think you spend many time, right? You may just pressing your calculator with 1 minute, even no need to spend 1 minute, even in 30 seconds, you already calculate control limit for X bar chart. And then another 10 seconds maybe for control limit for X chart control limit. Yeah, it's very simple. You have to try to press the calculator to get the experience. Have you done? Yeah. So hopefully the first time to calculate the control limit is not in your midterm test or it's not in your final exam. Okay, so hopefully it's not the first time. I mean, you don't calculate the control limit for the first time in your midterm test. Hopefully this will not happen, because I have discussed with you many times how to calculate. Because we do online class, so I don't know whether you try or I don't know whether you try or you didn't try. So you have to discipline yourself But I will demand you, please try to calculate by pressing your calculator. Please try. If you are busy to eat your breakfast, I think you also can try to press the calculation to calculate, right? To check the calculation. Okay? Sambil makan, sambil tekan calculator, sambil say, lihat jawapan betul tak? So this is not a conflict, right? You don't say, sir, I cannot press calculator. Why? I'm eating my breakfast right now. You use two hands? Not necessary, right? Bukan guna dua tangan. So one hand maybe you hold your food, another hand you can press your calculator. So you can do thing with different hand. So not a problem. Unless you eat a big breakfast, you need to use your two hand. Now, of course, you don't have free hand. You wish you have the third hand to press calculator. Again, I want to emphasize that after the calculation, we should able to interpret. You look at the last sentence. Yeah, on the screen, read the last sentence. Control chart are shown in figure 6.17. So this sentence tells us that the control chart, we can see the control chart from figure 6.17. So this one later you need to try. Okay, you have to try to plot the control chart, to plot X bar and S control chart. See whether you get the same pattern or not. Yeah, maybe later we can try to discuss how to plot that control chart by using Excel. And then the next sentence, there is no indication that the process is out of control. So this is very important because this is from our observation. Okay, from our observation from the control chart we plotted. There is no indication that the process is out of control. So those limits could be adopted for phase 2 monitoring of the process. So no indication, no out of control. The process is in control. The process is not out of control, right? The same meaning, right? When I say process is in control, or I say the process is not out of control. The same meaning, isn't it? So we just use the word, we use the sentence to present the same things. So those limits could be adopted for phase 2 monitoring of the process. So this is the interpretation after we plot X bar and S control chart. Even in S bar and R control chart, we also will use the same sentence to interpret, to explain. Is it ready? No out of control? Yeah, all the sample points are inside the control limit for S bar control chart and S control chart. You see, they are inside the control limit. But one thing you can observe from the figure B, figure 6.17B, you see the control limit. Okay, figure B, the control limit from 0 to something like to 0.01 something, or from the calculation is 0 to 0.0196. So from here, maybe some of you might ask, sir, is it possible our lower control limit negative value? Okay, this is another question. You don't ask, so I ask for you. But I ask for you not means that I should answer for you. Okay, I ask the question because some of you might ask this question, but you feel shy to ask. So I ask for you. But when you ask the question, not necessarily I should give you the answer, right? You can ask, but this is not the compulsory saying that you ask the question, circuit must answer you. So from this calculation, yeah, the question is it possible lower control limit can be negative? Question mark. I don't want to answer this question. But when I see the answer, I will mention to you. Okay, so for what we have discussed today, make sure you can calculate. Okay, make sure you can do the calculation, and make sure you can calculate for control limit. Okay, make sure you can calculate the control limit for X bar and S control chart. Yeah, of course, make sure you can calculate from the table. If you only have calculator, then you need to sum out. Okay, you need to sum one by one for sum of X bar, for sum of SI. And then you calculate the mean or you calculate the average. And then you plot the control chart. Yeah. So we have calculated the first, okay, we have covered the first case. If you still remember, in the beginning, we have mentioned that we have two cases. This is the first case. Okay, let us double check. Sample size n is moderately large, say n greater than 10 and 12. And then second case, the sample size n is variable. For the second case, we will discuss tomorrow. So make sure you really understand the first case. And then see 10 n greater than 10 or 12. From where we can see this information? Yeah, maybe from here, right? One, two, three, four, five. Subgroup still 5. Compared to S bar and R control chart, we also have 5 subgroups, isn't it? And then sample number 1 to 25. In the previous, for this one, example 6.1, we just want to simply compare. Any different? 1 to 25, the same. 1, 2, 3, 4, 5, 5 subgroup. And then sample size 25. And then for S bar and S chart, also the same, right? Then where is the first case mentioned? N greater than 10 or 12. Nothing different, right? If you compare X bar and R chart, S bar and S chart, nothing different, right? I mean, we still have sample size 25 and then subgroup 5. Then how about the first case mentioned? I mean, the information here. Or does it mean we can take subgroup more than 5 or more than 10? So you see observation 1, 2, 3, 4, 5. So does it mean we can take observation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Which one? This one, leave for you. We still have 10 minutes to go. Okay, go to Excel. If you get ready the data in table 6.3 with you, okay, this one. Yeah, I have get ready. So these are the sample. Okay, so these are the sample. Okay, so we do as usual. Along the line, along the row, okay, along the row, I have prepared the command. If you can see from the screen, so this is the command we use to calculate the average along the first row. Equal average, and then in the bracket, B5 to F5. And then enter. You can do the first one and then drag. Okay, drag until here, 25. And then get the sum. Use a command equal sum. So from the first value is at G3, G5. So you highlight G5 until G29. And then close the bracket, enter. And then calculate the average. So here I show you the command. So we just type equal average and then G3 until G29. So this is one way to calculate the average. Or another way, we can just simply take the sum 1850.029 divided by, you see, they are 25, right? So just take or just click on G3 to G30 divided by 25, enter. So we should get the same values. These values are referred to average. Okay, average diameter. And then doing the same thing for standard deviation. But how to calculate this standard deviation? Zero point zero one four eight. Yeah, 0.0148. So use the command standard deviation.s, stdev.s, and then highlight the first rows from B5 to F5, and then enter. Again, we can drag to fill in the column until here. Just now we have done these three columns, these three values, isn't it? So we can just simply highlight and drag. Okay, simply highlight and drag to the next column. Yeah, you can click on it to see whether we read the right value or not. And then I move X bar value into I column. Okay, so I just simply put equal G5 and then drag. So my aim is just to want to put all the value. Okay, I want to put all the value together when I want to plot the control chart. And then calculate the X bar bar. So to calculate X bar bar, so just simply click on this value. Okay. The mean of the mean or the average of the process average. So we have calculated just now, right? Then that value, the average value is at G31. So remember, the first value is read from G31. So the second value is not read from G32. The second value is read from the first value in the same column. Then you can write the second value until the end. Of course, this is one of the way we use the Excel to plot the control chart. If you plot the control chart by hand, okay, if you plot the control chart by menu or by hand, so actually you no need to calculate so many X bar value. You only need to calculate one X bar value is enough. Why I calculate so many X bar value is because I want to plot the line, center line in the control chart. Okay, so this column, you see all the value are the same. So when I highlight this column, then I will get a horizon line along 74.001. So I will get a solid line along this value. So I put this column with the same value because when I highlight it, I will get a line in Excel, in the Excel graph. And then for control limit, before we can calculate control limit, if you notice that, we need to know what is X bar, right? Okay, calculate X bar, you can read the value from H30, H30. Okay, either you read equal to H31, and then the second, you can do as what I did just now. Okay, the second one read the first one, or you can just follow. You put the dollar notation, and then drag from the first until the end. We use the notation dollar to fix the value at the H31. And then use the formula to calculate control limit, X bar, UCL, LCL for X bar, X bar control limit, X bar charts control limit. So after that, we complete the columns and then highlight these 4 columns to get the X bar control chart. So this is X bar control chart. Okay. And then doing the same thing for S chart. This one you try. Okay, for S control chart. So just now we have calculated lower control limit is equal to 0. Upper control limit, use the formula. So remember, we need to read the value B3 and B4, capital B3, capital B4 from the table, and then substitute into the equation. Again, I put 4 of them, 4 column value together. So when we plot the control chart, so I just highlight these 4 columns and then just simply plot the control chart. Okay, so please spend your time to plot the control chart for what I demo to you just now. So any question from you? Yeah, if no question, we will stop at here. So tomorrow we will continue to sample size is variable. For those who haven't get ready your data, so please prepare your data in table 6.3. hopefully tomorrow when we plot the control chart, yeah, especially for sample size is variable, then we need to calculate something before we can plot the control limit, before we can calculate the control limit, and before we can get the control chart. Okay, if no question from you, we meet again tomorrow online. So tomorrow class also online. So see you online tomorrow. Bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.